Hey everybody, today we're going to talk about how to graph electrocardiograms in Python. This tutorial is going to assume that you're basically completely new to Python. I'll try to explain everything, every line that I write, so that folks who are newcomers can still follow along. We're going to be using a site called Kaggle. Kaggle is a place to write code and find free data sets on all sorts of things. Healthcare data, real estate data, anything you can think of. Kaggle is totally free. You can go make an account for yourself right now, and then you can open up our code that we're about to show you and start playing around with it yourself. For this tutorial today, we've uploaded a data set of EKG data that you can also copy and use. It will be available in the notebook that we publish at the end of this video, and the link will be in the description. Kaggle is the kind of site where you can write Python code, write R code without having to download or install anything on your own computer. You just go to kaggle.com, make an account, create a new notebook, and you can start coding right away. It also has a bunch of free data sets. We have F1 data, mental health data from surveys, data about stores. So if you want to, go on over to Kaggle and make a free account, and then you can come to this data page, which will be linked in the description, and you can just click the options, click new notebook, and then it will automatically make a blank Python notebook for you. Alright, let's go ahead and name this graphing an EKG, electrocardiogram. And just so you know, EKG means electrocardiogram, so does ECG. The discrepancy comes from the fact that EKGs get their acronym from the German word, which has a K instead of a C, but EKG and ECG are the same thing. So what we're looking at right here is this default code that Kaggle provides. It's importing some libraries, which are the formal name for add-ons for Python code. Python doesn't immediately come with everything. It's like you have your regular Lego sets, and then you have these add-on Lego sets, or you have DLC, like for a game. You can think of Python libraries as like a DLC that's free, that does special things that you want it to do. For example, NumPy, really good at numbers and advanced math things. You can see this comment here says, this library is for linear algebra and other sorts of advanced math. And then we have another popular data science library called Pandas. Pandas is good for opening data files. Pandas is probably the most popular data science library for Python. It makes it easy to open files, easy to change rows, delete columns, manipulate data, all sorts of things. It is the go-to data science tool for Python. What we're actually going to do is delete everything but these two first lines that import these libraries. There are some other things you can import into Python, like you can import math. You can import date time to make it easier to work with calendar dates and times. You can import random to generate random numbers, all sorts of things. But for now, we are actually going to use just two libraries. One is going to be pandas. We'll keep that line. We're going to import a graphing library called matplotlib. We're actually going to import just a sub-library, like a smaller subset of this Lego set that we're importing, called pyplot. So we're going to do import matlib.pyplot, and we're going to rename it so that we don't have to keep typing out matplotlib.pyplot every time we want to use it. We're going to rename it as plt. So what we have so far is import pandas, renaming it as pd so we don't have to type it out, and then import matplotlib.pyplot as plt, again renamed. And this is pretty common in coding. You'll import this big library with this big ugly name, and you'll rename it as like a 2-character thing, just to make it easier to type later in the notebook. Alright, let's run those. Here on the right, you'll see that the notebook is starting. Before we hadn't run any code, so the notebook was just sitting there kind of asleep. So now it has to start up. It has to download the data at the top. You'll see the progress bar at the top. This particular database is actually about 10 gigabytes, so this is going to take 5 minutes. We're going to skip it in the video. Alright, our data is loaded. It loaded the entire database. However, it loads on the Kaggle server side of things, so if you have a slow internet connection, you shouldn't have a problem. You can see on the right side that this whole notebook is ingesting this data from the normal sinus rhythm database. And we'll talk about what normal sinus rhythm means in a second. Alright, let's use pandas to open the data. Pandas comes with a really convenient function to open files called read CSV. Now if you look at the data on the right, if you open this little drop down, you'll see that the EKG data is in a CSV format. You can think of CSV as like the most simple form of an Excel spreadsheet. If you've ever looked at an Excel spreadsheet and been like, okay, how do I run code on this data without Excel to manipulate it? You can make it into a CSV file and then feed that into your code. And it's like a super bare bones, dumbed down version, but all of your data stays the same. It's still in rows, still in columns, still has all the header names. And that will make it easier to manipulate that data in Python. So let's open the data. What we're gonna do is create what we call a variable, which is just a thing that holds data. If you're super duper new to Python, you could make a variable called a and set it equal to 5. Or you could set it equal to a sentence. And you can store that in your program and then run stuff on it. Like you could say, okay, I want A to equal 10, and then I want B to equal 5. And now Python knows that you have these variables. It can remember that A equals 10 and B equals 5. And then you can say, hey, I want to add A and B together. And then you can print that out. You can add them. You can say C equals A plus B, which is going to equal 15. So we'll run that. And you can say, hey, Python, tell me what the heck C is. You can use what's called the print function, which just writes stuff to the screen, just as it is, as text. You can say print C, and right here you see that it printed 15. We won't get too much into variables right now. I think as you see the code play out, you'll kind of be able to see how it makes a graph. Just a second ago, I had mentioned something called a function. A function is like a way to repeat doing an operation on a thing. You just feed a number into this black box and the function does it, and then it spits out an output the same way every time. For example, Python has a random function. Remember earlier we had used an example, import random, where Python imports the random library, and then we can use the random function to generate a random number. Anytime you see a word and then parentheses after, just think of that as a function. And then the parentheses are where you can feed in options into the function so that it changes how the function runs. The next step is to actually open the file. What we have are a bunch of CSV files. In the data itself, we have EKG files, and then we also have annotation files to go along with those, where actual doctors looked at the EKGs and labeled each heartbeat or event in the EKG and said, okay, this is a good heartbeat, this is a bad heartbeat, stuff like that. In this particular data set, all of the heartbeats are assumed to be normal. In order to call functions that Pandas owns, all we have to do is write pd dot whatever the function's name is. So if our function's name is read underscore CSV, then we just type pd dot read underscore CSV. Every time you see parentheses, just think function. So to open our CSV file of actual EKG data, we really need 2 lines. The first one is going to assign the actual path, the file path of the EKG to a variable, like how earlier when we did A equals 5 or A equals a sentence, we can assign A to equal the actual full path to the file, and that's like, okay, we can set A to the value of the file path itself by putting it in quotes. We can do single quotes or double quotes, either works in Python. So we're going to do single quotes and then just paste. Over here we copied the full file path by clicking the copy file path icon, and then we're going to paste into A the full file path, which you see is just a bunch of folders and then the file path itself. So we got Kaggle /input /datasets /proto, blah, 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 blah. And then at the very end is the name of the actual CSV file itself. And we're actually going to rename this to not being A because it's not descriptive. We're going to name it file path. And then all we have to do is say, hey, pd.readCSV, we want you to read the CSV that we renamed as file path. It's stored in the file path variable, as we call it. Then the last thing we have to do is we want to assign the output of readCSV to its own variable so that we can then manipulate that variable, perform other functions on that. So all we have to do is, let's call it EKG equals the output of read CSV. Then when we run this, the EKG variable will hold all of our EKG data, all of the rows, all of the columns. It will have all of the headers appropriately named that tell us what each column means, and so on. So let's run this. On my keyboard, I'm pressing Shift Return to just automatically run this what we call a cell of code. Or I can choose the cell and press this triangular run button up at the top, but I'll press Shift Return. And you can see on the left it's loading the EKG file. This should stop in a couple seconds. That actually took a little longer than I expected. I forgot that these particular EKGs are at least 500 megabytes. This particular data set has EKGs that are 30 minutes long, which is a lot of heart data. All right, now that we have loaded our file, our CSV, into the EKG variable, in order to look at that data, all we have to do is type EKG and run that cell. So now we have a spreadsheet-like preview of the data. We have 11 million rows and 8 columns of data. Oh, it actually looks like this data is 24 hours long, so this isn't a 30-minute EKG, this is like 24 hours at least. Again, lots of data. 11 million rows is quite a bit. So what are we looking at? We have timestamps. You can ignore this unnamed column for now. It's actually just a duplicate of the number of the row. We have 2 voltage channels, and then we have the annotations. When I made this data set, I took the annotations that I had mentioned that physicians make, and I combined them just to make things easy. But what we really care about are these 2 voltage channels. This is the actual heart data. Or what we're going to see in a second when we graph it is going to be something like this. This is 1 heartbeat. When we graph 24 hours of data, we're going to see a lot of these. There's going to be, if a person's heart rate is about 60 beats per minute when they're just chilling, that times 60 minutes in an hour times 24 hours, there's going to be thousands of heartbeats. So how do we graph this? Well, thanks to the Pandas ecosystem, Pandas is actually one of several of the quote-unquote popular data science libraries or add-ons for Python. And so is matplotlib. It's one of the go-to libraries. Pandas makes it super easy to graph stuff. In fact, we only need 1 line to graph one of the channels from the EKG. We'll graph both, but let's just pick one. We're going to pick voltage channel 1, MV. MV stands for millivolts because we're measuring electricity. All we have to do is grab just this 1 column, and we do it with brackets and single quotes. We could also do double quotes, it doesn't matter which. But we're going to say, hey, from the EKG data, we just want this column, and we're going to plot it. And all we have to do is run just this by itself. And it's going to create a graph, thanks to matplotlib, of the entire 24-hour EKG. And looking at this is kind of useless. This is just a big blob. This doesn't tell us anything about the heart. But it is in fact graphing the entire 24-hour data set. So what we're going to do is actually zoom in on the data itself. Again, you're seeing this dot function notation with the parentheses. What we're doing is saying, hey, on this particular column, we want to run the plot function. And because Pandas and matplotlib work so nicely together, they were made to work with each other, you can run matplotlib functions like plot directly on Pandas things. We actually call this thing that Pandas opened is called a data frame. And in data science, that's just kind of the word for a chunk of data, a CSV, an Excel spreadsheet-like thing that just holds rows and columns and data in many dimensions. We call it a data frame. So with our EKG data frame, we can say, hey, pick this column, run plot directly on it, and just show us what you got. Show us everything. Likewise, we can change it to the other voltage channel. We can just change the 2. Up here it was called voltage channel 2, MV. We can change that. We can plot the second channel, and it's probably going to look about the same. Big blob. Looks a little different, but again, doesn't tell us a ton about the heart because we've zoomed out to this person's entire day. All right, what we're going to do next is zoom in on the data to see some real heartbeats. What we're going to do is tell Python, hey, get just the first 300 rows of data. And that should be enough to be just a few heartbeats. Again, we had 11 million rows for 24 hours of data. So if we get just the first 300-ish, we'll be able to see some actual peaks, kind of like this, for real heartbeats. All right, so this is going to look a little weird. We're going to do EKG. We're going to use the same channel. Actually, let's use channel 1 again. Voltage channel 1, MV, and then to get just the first 300 data points, we're going to use brackets again, and we're going to write 0, semicolon, 300. And this says, hey, Python, I want just, from this particular column of voltage, I want just data points 0 to 300. And remember, in coding, computer science, all of that, indexes start at 0 instead of 1. So if you have a list, expect for that list of things for the first one to be called item 0, so to speak. So we're getting the first item, item 0, to item 300. So now if we actually run this cell by itself, the Kaggle notebook will print out just the first 300 items, 0 to 299 actually. All right, so let's leave that as it is. Let's copy paste to the next cell so we can run it separately. All right, so we're going to take the EKG, channel 1, just the first 300 data points, and on that, we're going to run the plot function, dot plot parentheses, and then we're going to run that cell. And boom, that's 4 heartbeats. Okay, what if I want to see the next 4 heartbeats, which will probably be data points 300 to 600 or so? All we have to do is change what we call indexes or indices that we use, just change it from 0 to 300 to 300 to 600. And we will replot that. I'm going to press Shift Return to run this cell of code. And boom, that was the next 4 heartbeats. It looks like it chopped off the last one. If we want to see the rest of this, let's change it to like 650 or so we can get that last heartbeat. Rerun that. Okay, now we have the next 4 heartbeats. So we just saw the first 4, then we have heartbeats 5, 6, 7, and 8 that we're looking at right now. All because we grabbed one column from the EKG data frame, and then we said, hey, I only want to see 300 or so data points with this bracket and semicolon notation. And then with all of that, we just ran dot plot parentheses, and matplotlib understood exactly what we wanted it to do, and it plotted this graph of EKG, or EKG data. Another thing we can do just for fun is add a title to the graph. Let's change this back to just the first 4 heartbeats. So we'll do data points 0 to 300. All right, we have the first 4 heartbeats. To add a title, we're going to use a function under matplotlib called title, easily enough. So what we're going to do is we don't have to reference this data frame. We can just do plt.title. Remember that we renamed matplotlib up at the very top as plt so that we didn't have to type everything again. So we're going to add a title with plt.title parentheses, and our title can be first 4 heartbeats. What was our patient's ID? The patient ID was 16265. So we can say from patient 16265. And then I'm going to run the cell again with Shift Return on my keyboard. Boom, and now our graph has a title. So what are we looking at? We're looking at 4 heartbeats, but what's all of this going on in between? Actually, what we're seeing is these peaks that are called R waves, and we're seeing these other peaks that kind of accompany it on both sides. What an EKG is doing is eavesdropping on the electric field that the heart is giving off as the muscles squeeze. It's really hard to see because this particular EKG is noisy, it's very jagged, but you might be able to see, like, look at to the left of each big R wave, there are these little peaks that happen just before it. You should be able to kind of see, they poke up just a little bit. These are called P waves. And there are other waves, there's the P wave. This is all in alphabetical order. There's a P wave, Q, R, S, and T. These are all supposed to happen in a particular order. They're supposed to have a specific height and width. They need to be a specific timing away from each other. So when doctors and nurses and paramedics are looking at your EKG, they're looking for these waves and saying, okay, is this wave this tall? Is it this many milliseconds away from the R wave? Is it too late? Is it too soon? Or does it exist at all? Did that wave not happen? Are things out of order? So when a doctor is looking at an EKG, they're really eyeballing it for that. And what we're going to do in this series is use our eyeballs to then write code to take over some of that work for us. Instead of looking at a thing and saying, oh, I think the P wave is 20 milliseconds away from the R wave. We're going to identify the P waves and the R waves and the Q waves and all of that with code, and then have the computer measure their timing. So this graph has a ton of noise, a lot of jagged lines that don't make it obvious to newcomers what the heck we're looking at. A smoothed EKG will look a little bit more like this. Let's talk about what these waves mean in a super simplified version. What we're really seeing is the top half of the heart is contracting, and then the bottom half of the heart is contracting. Now, if we look at the actual heart, there are 4 chambers. There are the top 2 atria and the bottom 2 ventricles. When we're looking at an EKG, we're really looking at the timing of when these are squeezing. We want the atria to contract before the ventricles. So when we're looking at an EKG, we are seeing the P wave, which is the atria contracting, and then the R wave is the ventricles contracting. And the reason why the R waves are so much bigger is because all the atria have to do is pump the blood from themselves to the ventricles. It's just pumping blood to their neighbor, which is right below them, which is why the voltage for the P wave is so small. The atria contracting is almost nothing. And then the R waves, when the ventricles are contracting, these 2 bottom chambers, these are either sending blood to the lungs through the pulmonary artery or out to the whole body through the aorta. That takes a lot more work than just sending blood from the atria to the ventricles. So the voltage of that squeeze is so much bigger than the P wave is, than when the atria contract. But basically what we're looking at in this rhythm is atria contracting, then the ventricles contracting. But then what is the T wave? The T wave is actually an electrical reset. No contractions are involved, it's just all of the cells in the heart resetting for the next heartbeat. And when this is off, when the cells are not resetting properly, then the shape of the T wave will change, and doctors will say, hey, your T waves are a little messed up. Probably your heart's not resetting accurately, which means that you might have heart disease. But again, this video is not medical advice. If you have concerns about your own EKG or your heart, or somebody else's EKG or their heart, please contact a licensed physician. I am not a doctor. So again, from the top, that's P wave, atria, R wave, ventricles, T wave, reset. Looking at this continuous EKG, we have atria contract, R wave, ventricles contract, and then the T wave, that's the reset. And again, atria, ventricles, reset, atria, ventricles, reset. Now the T wave is actually just the ventricles resetting. The atria reset sooner than that. The atria reset when the R wave happens, but the ventricles contraction that creates the R wave is so electrically loud that it just drowns out the atrial reset. But you can think of the EKG as atria contract, ventricles contract, reset. Okay, last 2 things we're going to talk about is what does normal sinus rhythm mean? And what do rhythms look like when they're bad, when they're not normal sinus rhythm? Okay, the name normal sinus rhythm comes from the rhythm being normal, go figure, and the rhythm originating in the sinoatrial node. The sinoatrial node is the cluster of natural cells in the heart at the very top that is the pacemaker for the heart. Not like a metal pacemaker like a device. We call it the pacemaker of the heart. It's just a bunch of heart cells that kick off the rest of the heartbeat. So when somebody has normal sinus rhythm, we say their rhythm is normal, and it looks like it's being kicked off where it's supposed to be, in the sinoatrial node. So what do heartbeats look like when they're bad? Here's one type called atrial flutter. We can see peaks for R waves, but the stuff going on in the middle is super duper whack. We don't see normal P waves, normal T waves. We see about 3 sawtooth looking waves. This is called a sawtooth pattern, which is typical for atrial flutter. And what's really happening is the atria, if you remember the 2 top chambers, the atria, instead of the SA node being what kicks off the heart, these atria muscles are just fluttering. They're just like contracting and being weird. So they create these 3 bumps 3 or more bumps in a sawtooth pattern in between the R waves. So the atria is kind of like dancing around, being a goofball, and then it will eventually kick off an R wave and the ventricles will contract. But what's going on between each real heartbeat is some goofy stuff. Here's another type of arrhythmia called a third-degree AV block. This is when the heart signal is starting at the sinoatrial node, but it's getting blocked. It's not making it to the ventricles and causing a real heartbeat. What we're seeing is these little bumps or nothing else is happening around them. That's a P wave, but then the signal gets stopped at the AV junction, which is in the middle of the heart, and it's not making it down to the ventricles. Here's another type of arrhythmia called a STEMI. This, though again, I'm not a doctor and I can't diagnose you or anybody or give medical advice, this is pretty deadly. What's really happening is we see, again, the big R wave spikes. We see a P wave. Okay, cool. The R wave is happening. Awesome. The ventricles are contracting, but they're not contracting all the way. And then they're failing to reset appropriately, which is not good. What's really happening is that the electricity of the heart is traveling from top to bottom. It's kicking off in the top left in the SA node. We got the P wave, and then it's traveling down the middle, and all of the cells are squeezing, and then it gets to the ventricles, and those are squeezing. But as the electricity comes back up, it's getting stopped, so to speak. The muscles aren't fully contracting. They're almost doing their whole job, but because of cell death, the pump is not completing its job. So that's causing what we call ST elevation. We didn't go over the ST segment, but it's this little part that is not going all the way down. It's elevated, and we call that a STEMI, ST elevation. Myocardial infarction, that's the official name for when blood is not getting to where it needs to go in the heart and it's causing problems. Alright, I know that was probably a little more than you signed up for, but I wanted to touch on how the heart works, what we're really looking at when we're graphing an EKG. In future videos, we're going to get a little bit more into what all of these waves mean, how we can find them with Python code, how we can measure their size, how long they're taking, whether the timing of everything is as it's supposed to be, and then we'll talk more about arrhythmias and when bad stuff is happening to the heart. So if you have any questions, please leave them in the comments. If you have feedback on how I can improve, would love to hear that also. Thanks for tuning in, and I hope this was helpful. Have a good one.